Okay, so we're going to talk about some compound angle formulas, and there's a couple of them to look at. We're going to specifically focus on this relationship of sine and cosine. So the first one we have here, we'll call this, I guess, our first formula, is our sine x is equal to our cos, the only difference being what would be considered like a horizontal shift of pi over 2, and then to the inverted of x, so negative x. Now, when we talk about our waves, and it's kind of lagging a bit, we'll kind of draw a rough sketch here. Do you recall a sine and cosine wave? Do you remember a sine wave starts at our origin, right? And then at pi over 2, we hit a value of 1. And then at pi, we come back down. And then essentially the cycle ends at 2 pi, right? With our cosine, just a little different. And we end up at there, there, and there. Okay. And we're going to show this on a graph to be a little more accurate. But the idea is, if you remember transformations, okay, we can always apply our function transformations to these waves. And the idea of this is, this x here, we can kind of rewrite this bracket, because when we talk about transformations, we're usually used to having the x first, and then the transformation written after it. So if we were to rewrite this bracket, it would be negative x plus pi over 2. Okay, so now negative x, do you know what that would do to that wave, where it would flip the wave?
It starts at -1.
Sorry, what do you mean by starts at -1?
When x is 0.
When x is 0?
Yes.
Okay, so our cosine, if we have it this way, will it flip? Now, does it flip it on the x-axis or the y-axis? Do you recall?
On the x-axis.
Okay, good. So it flips it on our x-axis here. So if we were to compare the two, we have a cos, and then we have cos negative x. Do you see any difference between cos and cos negative x?
No.
No. There's been no difference here. I want to show you negative cos x.
Right.
Negative cos x will flip it on our x-axis, okay? Where this one is a horizontal flip. So this horizontal flip is on the y-axis. So in our case here, no difference between cos x and cos negative x, okay? Now, with that being said, we do have to apply our transformation. And our transformation in this case, if we look at it again, so our negative x is plus pi over 2, okay? Pi over 2, what does that normally do for us? What does that, in terms of transforming a function, if it's a positive value within our brackets, which way are we going? And what type of shift is it?
To the left?
Yes, we're going to go to the left. And we're going to go, in this case, pi over 2, which is like 90 degrees, right? So let's show that one here. Do I have that written up? No, I don't yet. So if we have cos bracket negative x plus, and let's get pi divided by 2. Okay, we've now taken this wave and we've shifted it. And in this case here, if you notice, did the shift go 9? Oh, and I should be in radians. So give me 1 second here. I'm gonna pause this and put it in radians. And I changed the x-axis so that we were written as in terms of our pi here. So, like I was talking about before, and we'll get rid of the orange one here. Our blue graph here, we said that normally a positive pi over 2, so written here, positive pi over 2, would shift our graph to the left. But what does it look like it's done here? Which direction has it shifted it?
To the right.
It shifted it to the right, okay? And there's a reason for this, because our x is negative, and we're usually used to working with positive x's. So let's go down and think about this idea if we were transforming a function. So if I was transforming a function, right, it's usually written as f at x is equal to, and we have our a of whatever function it is, and in this case we're talking about cos, right? And we have bracket our k. I think you guys use the letter k, is that right? Yeah. And then x, is it d?
C.
C? Okay, so you guys C, and then d's on your outside? Okay, plus d. Okay, what's different about this is we're very much used to working with a positive value of x, and in this case it's technically negative. So this looks confusing if we were about to just set it up on our own. When we invert this and we rewrite it the other way, which I'll write below, we had our is equal to cos negative x plus pi over 2. So all I did was rearrange it so our x value was in front. I want you to think of our k value here like being a negative. Okay, this is a negative 1. And what I'm going to do is I'm going to factor out our k value, okay, so that we can get a better look of our horizontal transformation. So when we factor out the k value, what does this read?
Cos x negative 1.
Yep.
X minus pi over 2.
Yeah, exactly. X minus pi over 2. Oh, I should write that in green. Minus pi over 2. Okay, which means what kind of transformation do we have?
It moves to the right.
Yeah, which is exactly what we saw on our graph. Now, what I want us to do is essentially these, what they're saying, are exact equivalents. And it's true, they are. I can recreate what sine x normally does by writing cos this way. So if we notice, and I'll get rid of it, I'll get rid of both of them. Our sine wave is written this way, where we peak at 1, we're at pi over 2. And cos is just a little different. If we go right to here, it just overlaps what we had before. Unfortunately, it's the same color, but we can tell that it's overlapping what we had before. And all of these compound formulas are essentially transformations. Okay, all 4 of these are transformations of what the original does. So if we know how the original works, we can kind of work with these transformations. If we're able to mentally set up our graph, we can create our own compound formulas. Like I could set this up where it would be like cos x, and because it's a shift to the left, we can technically go cos x plus pi over 2, right? Because we know, whoops, lagging a little, sorry. Pi over 2 will shift my cos function back. And then that is the second one we have here. And we can write this many different ways. If I wanted to have 3 pi over 2, okay, that would be 3 movements, and I'd probably have to do a negative value for that to shift it all the way this way. So we can create our own formulas. That's all these are. So they want us to memorize them, but really we can recreate all of these as long as we understand our transformations well. This being a negative and these values being positive. And if you notice, because cos and sine are so very similar, these are almost identical in terms of their formulas. Sine x is equal to this relationship here. And this is the same relationship here where we factor out the x, and it's actually a shift of negative pi over 2. So it's moving it 2 to the right in this case. And then same idea here. These are very similar ideas, okay? In fact, these are almost identical except that they factor out our negative value here. Okay, so you have a question written there, and I think it says, I'll try to address it. Sort of example 1. Given that sine pi over 6 is equal to a half, use an equivalent trigonometric expression to show that cos, that's not cos, that's sos, show that cos pi over 3 is equal to a half. So I think the goal here is what they're trying to do is draw some relationship between these. So we might want to work with either converting our cos into a sine or our sine into a cos. And we can use the formulas we have above, or we can try to create our own. Okay, so let's look at some of the formulas we have above. And since we start with sine, we'll try to convert it. Where you start with sine, we'll see what sine, and this represents our x value, right? So we'll work with the 2 formulas where we have sine x. And in fact, this one's negative. So really, this is the only one that directly works with what we're working with. So let's use this formula here. Sine x is equal to cos pi over 2 minus x. So with that being said, sine x is equal to cos pi over 2 minus x, right? Okay, well in this case, our x value is our pi over 6. So essentially we can replace both of the x's with a value of pi over 6. So as we go through this, we have sine pi over 6 is equal to, and we're going to focus, sorry, How do we get trouble with that? Cos pi over 2 minus pi over 6. Okay. Let's take a look at this idea. And let's see if we can kind of work of what we have here. Sure. There we go. So in order to simplify this, we need our fractions to be the same. Right? So let's convert this to a value of 6 here. So we have cos. What would this be as a fraction if we need the denominator to be 6? Yeah, that's right. 3 pi over 6 minus pi over 6. Okay. And what is 3 pi over 6 subtract pi over 6?
2 pi over 6.
2 pi over 6, which can be reduced to?
Pi over 3.
Yeah, cos pi over 3. Now, do we know any relationships like that have cos pi over 3? Do you know any special triangle relationships or anything like that deal with that value? Do you recall any off the top of your head? Yeah?
No, not.
Okay, let's try to create one. Okay. So we have our special triangle here. And we're going to try to see if these are equivalent. Now, remember, at the beginning of the question, they told us that this was equal to a half, right? They said that this value, pi over 6, is equal to a half. We have one special triangle here. It works with 90 degrees, 60 degrees, and 30 degrees. And do you remember the ratio of this triangle, how it's all set up?
1, 2, and root 3.
That's right. 1, 2, and root 3. Okay. What did they use? They used pi over 6. Now, if we were to convert these to radians, what's the process of converting degrees to radians? So if I have 60, how do I convert that to radians? What do I multiply by?
Times pi over 180.
Yeah, exactly. Pi over 180. Okay. Which becomes 60 pi over 180. How can I reduce those two?
That would be pi over 3.
Yeah, exactly. Pi over 3. Perfect. So we know that 60 is now pi over 3, which is, in this case, exactly what we're working with. We're working with pi over 3. Okay? So, cos. Do you remember what trig ratio cos is? What it's set up to be?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So if we look at our adjacent side, we have 1 over 2 in this case. So we've just proven with our special triangle and just plugging our value in that, in fact, these two are equivalent. Oh, sorry. I'll go up a little more. That sine pi over 6 is the equivalent of cos pi over 3. Okay? Pi over 6 is essentially this value here, right? If we were to turn 30 into radians, we multiply by pi over 180, which essentially becomes pi over 6. And sine pi over 6 is equal to what? Opposite over hypotenuse, so that's our 1 over 1/2. So using our special triangles, we've proven, and a little bit of algebra, that these two are actually, or in fact, equal to each other.